Good morning to everyone. Today I discuss the topic on variable reluctance type stepper motor. Previously previous I discussed the classification of stepper motor, or what is stepper motor, what are the application of stepper motor. Here I discuss the variable reluctance type stepper motor. Before going to discussion on variable reluctance type stepper motor has two important component. One is stator and second is rotor. Okay, rotor means which rotating, and stator means pole. Okay, there are two component, stator and rotor means which rotate and stator means pole. Okay, so and the rotor made by permanent magnet. Okay, rotor made by permanent magnet or ferromagnetic material. What is the ferromagnetic material? Iron is the example of ferromagnetic material. Okay, so this is the diagram of a stepper motor, variable reluctance type stepper motor. Variable reluctance means there is a air gap between. Firstly, we discuss the number of rotor teeth is 2, means this and this is the rotor, and teeth of the rotor is 2, 1 and 2, and number of stator pole is 4, 1 2 3 4. So this is the stator and their pole of the stator is 4. So there is a gap between teeth of the rotor and pole of the stator. This is called the air gap. And this air gap is different, means here the distance is small, so air gap is small. Here the distance is large, so air gap is large. And here also distance is small, so air gap is small. So distance is small, so air gap is also small. There is distance is large, so air gap is large. So in the variable reluctance means air gap is different at the different pole, so it is called the variable reluctance type stepper motor. So here we discuss the magnetizing of poles. Here the magnet, when goes through a current and magnetize the pole, when goes to the current, magnetize, the pole is magnetized. So if we consider, if current goes to the pole B, and this is the pole B, and this is the B dash, this is the pole A, and this is the A dash. So if the current goes to the pole B, so current goes to the pole B, this pole. So what happened? The magnetic field generate. Okay, so this pole is magnetized, or magnetic field is generated. So two pole is established. Okay, two pole. What is two pole? North pole and south pole. Okay, let's consider this is the N pole. Okay, and this is the S pole. Consider B is the N pole and B dash is the S pole. First, we also known B and B dash connected in series, and here is denoted, here is a series connection between B and B dash, and there is a series connection between A and A dash. So if we consider B, the current flow through the B dash, and if we consider A, the current flow through the A dash. So let's consider if B, N pole is generated and B dash S pole is generated. So consider this is the this is the rotor. Okay, consider, suppose rotor is N, this is the N pole and this is the S pole. Suppose the rotor already two pole, N pole and S pole. Consider this is the N pole and consider this is the S pole. So N pole of stator and N pole of rotor repulse each other, repulses. Okay, because this pole N and this is also N, so this is repulse, but this is N pole and this is the S pole, these poles is attract, and this is the repulse and this is the attract. So N pole of stator and S pole of rotor attract. Okay, because we already know that the opposite pole attract and same pole is repulse. So this is the same poles, so this is the repulse and this is the opposite pole, this is the attract. So this is attract at this side, so the rotor move to this side, this direction, rotor move, and this is called the step. This is called the step, and here the step is 90 degree, step angle is 90 degree. Okay, so rotor is moved from A side to B dash. Okay, then demagnetize the pole B. The pole B means the current is cut. Here first current is flow, this is the magnetized, and here the current is cut, so this is the demagnetized. So this is the demagnetized. So now consider B then A is magnetized. Suppose A is magnetized because the current flow through the A. So here suppose here N pole is generated and here the S pole is generated. Okay, here N pole is generated, here S pole is generated, and the rotor in its position, this rotor its position is here in this position when B is magnetized. When B is magnetized, the rotor move from this side, means this side rotate 90 degree, and here N is generated. Okay, and here S is generated because the rotor rotate when B is magnetized. Here the position of the rotor is this. Okay, then A is magnetized. A and A dash is magnetized. Suppose N pole is generated and A dash S pole is generated. So here N and S pole, here N pole is created and here S pole is created. So this is the attract and this is the attract, and this N pole and this N pole is repulse. So the rotor is moved from this direction, and this is also a 90 degree direction, and this is called the step angle. So if we magnetized from A dash, B dash, the rotor is stepping 90 degree. So this is called a stepper motor. Stepwise rotate. This rotate is step, means this direction, this, again this, and again this. Okay. So when IA is not magnetized, so when no current is flow, so the phase angle is 0 degree. When A coil is magnetized, IA current is flow. Okay, so when the IA current is flow, the rotor rotate from 0 degree to 90 degree. Okay, when B is magnetized or current flow in the B coil, so rotor rotate 180 degree, from 90 degree to 180 degree. When IA dash is magnetized, okay, IA dash is magnetized, so 180 degree to 240 degree. When IB dash is magnetized, okay, when IB dash is magnetized is 360 degree. So this is the stepwise rotate. When IA is magnetized means when IA is magnetized, when IB is magnetized, when IA dash is magnetized, when IB dash. This is the IA dash, and this is the IB dash. And this is the working principle of variable reluctance type stepper motor.